The story of rare earths began in 1787 in a quarry in Jitterby, a small village near Stockholm, Sweden. Carl Axel Arrhenius, an amateur mineralist, discovered a mysterious, heavy black stone unlike anything seen before. This stone turned out to be a treasure trove of new elements that would eventually shake the world. The village's name became immortalized in chemistry, serving as the root for 4 different elements: yttrium, terbium, erbium, and ytterbium. In 1794, Finnish chemist Johann Gadolin managed to extract an unknown oxide from this black stone. At the time, such oxides were referred to as earths, and because they were incredibly difficult to obtain, they were named rare earths. However, this name is somewhat of a misunderstanding. These elements aren't actually that rare in the Earth's crust. Cerium, for example, is as abundant as copper. Their rarity comes from the fact that they are extremely difficult to extract and isolate in their pure forms.
Throughout the 19th century, chemists were haunted by the task of identifying these substances. The 17 rare earth elements are so chemically similar that they were almost impossible to tell apart. Scientists of the era were forced into a grueling process called fractional crystallization, where they would evaporate and recrystallize solutions thousands of times to exploit tiny differences in solubility. Many new elements discovered during this time turned out to be nothing more than mixtures of 2 or more elements that hadn't been fully separated.
Rare earths first gained industrial value in the 1880s. Baron Karl Auer von Welsbach developed the gas mantle, a mesh treated with a mixture of thorium and cerium that was placed over gas flames. This invention made gas lamps significantly brighter, bringing rare earths into the light of the industrial world. He also invented the flint used in lighters by mixing iron and cerium, marking the first time these elements truly integrated into daily human life. As physics advanced in the 20th century, the secret behind the unique properties of rare earths was finally revealed. It was discovered that they possess a unique electronic structure known as the 4f orbital. This internal shell allows them to produce powerful magnetism and vivid light, earning them the nickname magicians of light and magnetism. With this scientific foundation, rare earths transitioned from being mere curiosities to industrial vitamins essential for high-performance technology.
Unexpectedly, the Manhattan Project, the development of the atomic bomb during WW2, accelerated the history of rare earths. To separate specific elements from the fission products of uranium, researchers developed a groundbreaking technique called ion exchange chromatography. This method revolutionized the field, allowing for the mass production of 99.9% pure rare earth elements and replacing the thousands of manual crystallization steps previously required.
From the 1960s through the 1980s, the global rare earth market was dominated by the Mountain Pass mine in California, USA. The catalyst for this boom was the color television. Europium became an indispensable component for producing the vibrant red phosphor on TV screens. To bring color into living rooms across the globe, American mined rare earths were shipped to every corner of the world. In the late 1980s, China entered the market, utilizing its massive reserves and low labor costs as strategic weapons. In 1992, the Chinese leader Deng Xiaoping famously declared, "The Middle East has oil. China has rare earths." China strategically invested in mining and refining technologies, and with fewer environmental regulations at the time, they flooded the market with cheap products. This eventually forced American and other international mines to close, giving China a monopoly of over 90% of the world's supply by the 2000s.
In 2010, following a fishing boat collision incident near the Senkaku Islands, China effectively halted rare earth exports to Japan. This rare earth shock sent shockwaves through the global high-tech industry. Prices skyrocketed, some by more than tenfold overnight. This incident served as a wake-up call for nations to recognize the danger of over-reliance on a single country, prompting a global rush to diversify supply chains, develop recycling technologies, and find alternative materials. Today, rare earths are the key to a decarbonized society. They are essential for the powerful magnets used in electric vehicle, EV motors, neodymium and dysprosium, wind turbine generators, and the high-performance speakers in our smartphones. The history of rare earths has shifted from a struggle of how to separate them to a geopolitical challenge of how to secure them. We are now entering a new era of deep-sea exploration, space mining, and the development of rare earth-free technologies.